we're going to use the chain rule to find the derivatives of these three composite functions involving tangent. I'll leave links in the description to similar lessons I've done with sine and cosine. If you need a refresher on the chain rule, well, here it is, and hopefully this, along with the examples, will help. At the end of the lesson, we'll also do a bonus example with this function, which is a little bit uglier. Let's begin with the first problem. We have the derivative of tangent of theta squared. So keep in mind, in this function, it's the theta that is being squared, and this is how that could be written. Now, to take the derivative, we first need to take the derivative of the outside function. That's what the chain rule tells us. We begin with f prime, the derivative of the outside function. The outside function here is tangent. Theta is being squared, but theta is inside of tangent. So the outside function is tangent. And what is the derivative of tangent? Well, that's secant squared. So the derivative of the outside function is secant squared. And remember, what's inside the derivative is g of x, the original inside function. We don't change the inside function. So the thing that's inside the secant squared is still just theta squared. Then, this gets multiplied by g prime, the derivative of the inside function. The inside function is theta squared, so its derivative is 2 theta, and that's the derivative of tangent of theta squared. All right, next problem, the derivative of tangent of 2 theta. Let me change to this shade of green. What is the outside function here? Well, again, it's tangent. The inside function is 2 theta, the outside function is tangent. So we begin with the derivative of the outside function, secant squared. Then, what do we do with the inside function? Nothing. That's right. So it's secant squared of 2 theta. Leave that inside function unchanged. Then, multiply by the derivative of the inside function. The inside function is 2 theta, its derivative is 2, so multiply by 2. You could put this factor of 2 in the front if you please, but it doesn't really matter. Final easy example, the derivative of tangent squared of theta. So notice this is how it's going to be written if the tangent function is being squared. The other possibility is that it would be written like this, tangent of theta in parentheses squared. That's another possibility. These are the same thing. But anyhow, the outside function in this case is no longer tangent. The outside function now is a thing being squared. So how do you take the derivative of a thing squared? Well, you have to take that exponent of 2 and bring it down as a factor, and then reduce the exponent by 1. It's just the power rule. But we're going to leave the inside function, which is tangent, unchanged. Its power was 2, but we brought that down as a factor and then reduced that power of 2 by 1. So now our power is 1, but of course we don't have to write that. Then we multiply by the derivative of the inside function. The inside function is tangent and its derivative is secant squared. So then we multiply by secant squared of theta. And there you go. Those are 3 basic examples of the chain rule with some tangent functions. Let me know in the comments if you have any questions, and maybe with that practice, you can go ahead and give this problem a try before I go through the solution. Hopefully you gave it a fair shake. Let's get into it. Begin with the derivative of the outside function. In this case, the outside function, just like in the last problem, is a thing being squared. So I bring that 2 down as a factor and leave the inside function unchanged. The thing that was being squared, the inside function, is tangent of e to the tangent theta. So this is what I've got now. Now I multiply by the derivative of this inside function. The inside function, of course, is itself composite, so we're again doing the chain rule. The outside function now that we focused on this guy here, the outside function is tangent, so I need to multiply by the derivative of tangent, which is secant squared, and leave what was inside alone. What was inside was e to the tangent, so it's secant squared of e to the tangent theta. Now I need to multiply by the derivative of this thing that's inside the secant squared. And what's the derivative of this? Well, again, it's a chain rule situation. It has an inside function, tan theta, and an outside function, e to some power. The derivative of e to some power is just e to that power. But because that power is a function, we also need to multiply by that power's derivative. That's the chain rule. We're multiplying by the inside function's derivative. And of course, the derivative of tan theta is secant squared theta. And finally, we have taken care of all layers of this composite function, and that's our derivative. I hope that was helpful. Thanks for watching, and check out my calculus exercises playlist for more practice. Reindeer to pick me up and slowly get to know me. We'll unwrap each other until we're never lonely.
Is it okay?